Welcome to the second video of the module 3. In this video, I am going to explain the solution of homogeneous and non-homogeneous PDE. The solution of non-homogeneous PDE is done by direct integration. In this method, we find the dependent variable which being the solution by remaining the differential operators through the process of integration. So let us see the problem. First problem, dou square u by dou x square is equal to x plus y. Solution, consider dou square u by dou x square is equal to x plus y, which can be also written as dou by dou x of dou u by dou x is equal to x plus y. Integrating with respect to x, treating y as a constant, we get dou u by dou x is equal to x square by 2 plus yx plus function of y as a constant. Again, integrating with respect to x, treating y as a constant, we get u is equal to x cube by 6 plus yx square by 2 plus x f of y plus g of y is the solution of the given PDE. How to do the solution of homogeneous PDE involving the derivatives with respect to one independent variable only. Suppose the dependent variable has been differentiated partially with respect to one independent variable, say x only, then the PDE can be treated as ordinary differential equation, and we are already familiar with solving the ordinary differential equation. So the arbitrary constants in the solution are then replaced by arbitrary functions of other variable y, giving the solution of the PDE. Let us see the problems now. Solve dou square z by dou x square plus z is equal to 0, given that when x is equal to 0, z is equal to e power y and dou z by dou x is equal to 1. This is the initial condition. Here z is a function of x only. So we convert the PDE into ODE. So it is d square z by dx square plus z is equal to 0. That gives us d square plus 1 of z is equal to 0. Replace d by m. That is, we'll get the auxiliary equation as m squared plus 1 is equal to 0. Solving this equation, we get m square equals to minus 1. That is, m is equal to plus or minus I. Here the real part is 0, imaginary part is 1. So the complementary function will be c1 cos alpha plus c2 sin c1 cos x plus c2 sin x. The solution is z of x is equal to c1 cos x plus c2 sin x is the solution of the ordinary differential equation. And c1 and c2 are respectively replaced with f of y and g of y. That gives us z is equal to f of y cos x plus g of y sin x. That's the solution of the PDE. Now we need to find the f of y and g of y. When x is equal to 0 and z is equal to e power y, equation 1 implies e power y is equal to f of y because sin 0 will be 0. When x is equal to 0 and dou z by dou x is equal to 1, we use dou z by dou x is equal to minus f of y into sin x plus g of y into cos x. That gives the solution as g of y is equal to 1, and on replacing we get the solution z of x. Thank you.